Hey guys, this is going to be a video going over the review for the upcoming test. Starting with question 1, it's a system of equations with two variables, and so let's solve it. I'm going to solve this by elimination, and I'm going to get rid of x here. So I need to multiply this equation by 6. The top equation is going to stay the same. The bottom equation, though, is going to be positive 6x minus 30y equal to 144. When you multiply 6 by 24, that's what you get. And then we're going to add these together. Those are going to become 0. And then we're going to get negative 24y is equal to 144. We're going to divide both sides by negative 24. And y is going to be equal to negative 24. That should be equal to 6, because when I multiplied 6 by 24, I got 144. And then whenever I divide, yeah, it should be negative 6. Man, I am missing my negative signs. So, okay. Now that I have y, I want to find the value of x, and so I'm going to do that by plugging in. I'm going to plug negative 6 into this equation right here. So when I do that, I get x. So if I plug negative 6 in for y, that becomes negative 5 times negative 6, so that's going to be plus 30, and that's equal to 24. Then I'm going to subtract 30, and then x is going to be equal to negative 6. So the solution is negative 6, negative 6. For number 2, this one's not quite, it's not too bad. Doesn't really matter if we get rid of x or y, but let's just multiply this by negative 2. So multiply this by negative 2, because let's say I get rid of the x. So when I multiply this by negative 2, it's going to become positive 6. But the top equation is going to remain the same. Plus 8y is equal to 14. Now when I multiply the bottom equation by negative 2, that's going to become 6x minus 8y equal to negative 10. And we're going to add them together. Now those are going to cancel, and those are going to cancel, becoming 0. And then the right side of the equation is going to become 4. And 0 does not equal 4. This is a false statement, and this means that there is no solution. Okay. Question 3. Notice that the top equation here only has one variable, so that means we can easily solve for this equation without having to do much. Right away, if I divide by negative 2 on both sides, you'll get x is equal to positive 5. So if I divide this by negative 2, it's just going to become x. If I divide this by negative 2, you're going to get 5. And since I have 5 for x, I can plug that into this equation. So 3 times by 5 plus 2y is equal to 3. And then that's going to give you, so subtract 15, because 3 times 5 is 15. Subtract 15, and you get 2y is equal to negative 12. Divide by 2, and you're going to get y is equal to negative 6. And it seems like we haven't gotten an answer or a value today that's not negative 6 so far, so that's cool. Oh, except for this one right here, we got 5. Alright, so now that I have y and I have x, I can finally use this last equation plug in 5 for x, plug in negative 6 for y, and then I can solve for z. So negative 4 times by 5 minus 5 times by negative 6 plus 3z is going to be equal to negative 2. This is negative 20 when you multiply negative 4 and 5. That's going to become plus 30 when you multiply negative 6 and negative 5, plus 3z equal to negative 2. And that means that this right here is going to be 10 plus 3z is equal to negative 2. Subtract 10. And then you get 3z is equal to negative 12. Divide by 3. And z is equal to negative 4. So my solution is 5, negative 6, negative 4. And there you go. Alright, let's try 4. Now this one, since it's not going to be like this one right here, where we don't have an equation that just has one variable. This is 3 variables in each equation, and so I'm going to solve by elimination. And I can get rid of x's pretty easily. I can get rid of y's right here. I can get rid of z's if I add these ones. So, I don't know, it doesn't matter too much about which one you get rid of. I'm going to get rid of z's. I like to, so this is my first equation, this is my second, and this is my third equation right here. So what I'm going to do first to get rid of z's, I'm going to add 2 and 3 together. So when I add 2 and 3 together, when I add these together, we add 2 and 3, I'm going to get negative x plus 5y. And then notice here that I have negative 2z and positive z, so those cancel. And then I'm going to have 7 and negative 4, so that's going to be equal to 3. And I'm going to call this my new equation. It's a new equation without any z's. I need another one, though, without any z's again. So let's get rid of, so I got rid of z by adding these ones together. I'm going to get rid of z again, and I'm going to add these two together, but I do need to multiply this equation by 2. So I need to multiply this equation by 2 before I add it with the other equation. So when I do that, I get 2x minus 2y plus 2z equal to negative 2. And then the second equation is x plus y minus 2z equal to 7. Now, when I add these together, those are going to cancel and give me 0 for those. So that's why I wanted to multiply the other one by 2. But this becomes 3x minus y. The z's cancel again, and that's going to be equal to 5. So this is my second new equation. Now, so I'm going to put new equation 1 and new equation 2 together. So negative 5 plus 5y is equal to 3, and 3x minus y is equal to 5. And alright, so let's see. I want to get rid of another variable, but I only need these two equations right here. So we got rid of z. Now we're trying to get rid of another variable. I'm going to multiply this by 3 to make this negative 3x. So let's multiply this by 3. So then I'm going to get negative 3x plus 15y equal to 9. And then the second equation stays the same. And now I'm going to add them. Negative 3x and 3x will go away. I'm going to get 14y equal to 14. and I divide by 14, divide by 14, and you get y is equal to 1. Okay, so y is equal to 1. And now I can start finding the value of my other variables. I'm going to go back up to one of these new equations, so one of these ones, and I'm going to plug 1 in for y. I think I'm going to do that here. So if I plug in 1 right there, I get 3x minus 1 equal to 5, and then 3x is going to be equal to 6 because I'm going to add it here and add it there, add 1 there. I'm going to divide by 3, and x is going to be equal to 2. Okay, so now I have y, I have x, now I need z. So I'm going to go up here and look at one of these equations, and I'm going to use this equation. But I know that x is 2, so I can plug that in here. And I know that y is 1, so I can plug that in here. So that's going to become 2 minus 1 plus z equals negative 1. 2 minus 1 is 1. Then I subtract 1, and z is going to be equal to negative 2. So my solution, x is 2, y is 1, z is negative 2. Alright, one more system of equation here. We're going to, z's are nice and easy right here. So I'm going to add these together and then those together. So when I add the first two equations together, that's negative x, and then that's going to be plus y. Z's are going to cancel, and it's going to be equal to 2. Now when I add these ones together, that's going to become 4x. This is going to become negative 4y. Z's are going to go away, and that's going to become negative 8. Now, let's get rid of x, but I have to multiply this by 4. So, negative 4x, and then plus 4y equal to 8. And this is 4x minus 4y equal to negative 8. And when I add them together, gone, gone, gone. So the left side is going to be 0, the right side is going to be 0. So this has infinite solutions. Okay. Question 6. So this is a word problem. We've got 3 orders that are placed at a pizza shop. 2 small pizzas, a liter of soda, and a salad costs $14. So 2 small pizzas plus a liter of soda plus the cost of salad. All of that is going to come to a total of $14. The next order, 1 small pizza plus the cost of a soda plus the cost of 3 salads is equal to $15. 3 small pizzas plus a liter of soda plus 2 salads, that's all going to come to a cost of $22. Now you can probably figure out through trial and error what the cost of all of these are, but it might be more efficient than to just use a process of systems of equations to figure this out. Now, the easy part about this is that all of these y values right here are, so each order only used bought one soda, but that means that's going to be the easy one to eliminate. So if I just multiply one of these by negative 1, that will be very useful. So let's just pick this middle one right here, but you can use any. But if I multiply this by negative 1, I'm going to still keep the top equation as is. The bottom equation is now negative, or sorry, the middle equation is now negative x minus y minus 3z, and that's going to be equal to negative 15. And then the bottom equation also stays the same. Okay, so I did that, so now it's going to be kind of easy to just add both the top two equations and the bottom two equations. When I add those together, I'm going to eliminate y, which would be very nice. Oops. Okay, so when I add the top two, 2x and negative x becomes x. Those are going to cancel, and that's going to become negative 2z. And that's going to be equal to negative 1. And then when I add the bottom two equations, that's going to become 2x. And then the y's are going to cancel, and that's going to become 5z. So plus 5z, and that's going to be equal to, is that going to be 7? 7. Oops. Ooh, almost made a mistake there. Hold on. When I add these together, that becomes negative z. And that's going to be equal to 7. So now I have two new equations right here. And I'm going to eliminate one of the variables in these equations. It doesn't really matter which one you pick, but let's just say I multiply this one by 2. So that becomes, no, let's not do 2. Yeah, let's do 2, but we got to make it negative. Okay, so that becomes negative 2x plus 4z. That's going to be equal to 2. And then the bottom equation stays the same. I can add them together now. Those are going to cancel. That's going to become 3z, and that's going to become 9. So therefore, 3 salads is going to be a cost of 9, which means 1 salad is going to be the cost of $3. So I know that salads costs $3. Okay. Now I can plug this value back into, let's say, here or here, whichever one. I'll plug it back in here. So we still have x. So x minus 2 times by 3 is equal to negative 1. So x minus 6 is equal to negative 1, which means x is going to be equal to 5. The cost of a pizza, small pizza, is $5 there. And now that I have those, let's go back to one of my original equations and solve for y. It doesn't matter which one. Let's just take the middle one that we had. Okay, so if I take the middle one, x was $5. We still don't know the cost of soda. Plus 3 salads, and salads cost $3 each for a total of $15. So 5 and 9. So y plus $9 is going to be equal to 15. So therefore y has to, I did not do that right at all, did I? Don't know what I was doing there. 5 plus 9 is 14. So y plus $14 is going to be equal to $15. So the cost of the soda has to be equal to $1. So pizzas are equal to $5. Soda is equal to $1. And then salad is equal to $3. And there we go. Let's see. I'm probably going to break this into 2-part video. So I'm probably going to stop it there, and then the next video will pick up here.